Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Hello, and welcome to the SEI Podcast Series. My name is Suzanne Miller, and I'm a principal researcher in the SEI Software Solutions Division. Today, I am joined by my colleague and friend, Tim Chick, the technical manager of the Applied Systems Group in the SEI CERT Division, to discuss designing secure systems. Welcome, Tim.
Thank you, Suze. Good to see you again.
So you've been on our podcast series before, but it's been a little while. So for those who don't know you, let's start by having you tell us a little bit about yourself, the work you do here at the SEI, and what's the coolest part of your job? That's my favorite question.
So the coolest part is to get to work with wonderful people like you.
Good one.
But in general, the coolest part of my job is really just being able to constantly learn, explore, and apply those things and on real projects with real customer problems. I find that very rewarding. A little about myself. I've been with the SEI about 17-ish years. Most of my time here has been really focused on software engineering practices of various types and constructs. The last decade or so have been mainly focused on cybersecurity aspects of the software engineering lifecycle. Really focused on how do I build, design, and operate secure systems, which is a slightly different perspective than maybe traditional cyber folks think about. Traditional cyber folks really focus on, here's my software, how do I build this moat and defend my castle, right? Where my goal is let's engineer a defensible and sustainable castle so I don't need all those moats and all that other nonsense around it. It's secure by design.
Exactly.
So that's really been my focus, especially the last 5-6 years.
And secure by design is a theme across all of CERT at this point. And so this is right in the sweet spot of where you guys are working. And so that's what we're here to talk about today. And as you mentioned, we're looking at building secure systems throughout the software development lifecycle, not just at the end. We're not bolting security on, as we used to say. You recently had a webcast, which we will link to in our transcript, and you talk about the scope of insecure system design, which I found very interesting, and the problems that can arise from insecure system design. So how big a problem are we talking about?
Yeah, so the problem is we think about 9 out of 10 breaches are due to defects in design and code, right? The average data breach in 2023 cost a company almost $4.5 million, right? So there's a huge tangible dollar amount. It actually impacts our U.S. economy in the trillions of lost productivity due to cybersecurity breaches and lost data and things of that nature. And also it impacts us not just from a data perspective, but even physically, right? I mean, there are examples of people, destroying physical property through access via the internet, right? And so this whole cyber physical aspect just compounds the issue because it's not just the internet, it's actually people's safety can be affected by
right.
And conveniences, electric power grid, air conditioning in these hot summer days. So all those things are now impacted by the internet, right? Because it's interconnected world.
And so secure design does not mean that we eliminate all those problems, but it does mean that we eliminate, as you said, the largest problem, which is the defects that are in the code that lead to vulnerabilities and that sometimes lead directly to issues. So what are some of the barriers? Why don't people, if this is such a problem and it has such big effects, why don't people just build secure systems?
Because it's hard, right? I mean, it's engineering, right? And part of it comes to, as a software industry in general, while software has enabled amazing things, we're actually not very good at developing defect-free software, right? If you think about anytime you open an application or you do anything, you click those README files, there's license agreements, right? That probably most people hardly ever read. But if you actually read it, it actually says user beware, right? It's you use at your own risk. If this breaks something, causes harm anyway, it's your problem because you chose to use it, right? That's basically what a user agreement says. And part of that comes from is they're almost always defective, right? Quality is a major core issue. And the problem with that is we've done some studies, and 1% to 5% of every defect is actually a security vulnerability. It's something that could be exploited. And so it just compounds our poor quality ability with that. That said, there are things one can do to mitigate or reduce the risk of developing insecure systems, right? And start thinking about security as a design constraint and as a design element. And there's practice you can think about. And part of that is developers in general are very positive people, very confident in their abilities. And so what they don't think about naturally is how could someone misuse or abuse a feature that they're giving someone, right? Because reality is, especially in Agile, the biggest thing is the valued customer. The customer wants X, I'm going to give them X. Well, from a security perspective, you have to say, okay, customer wants X. Let me step back and go, how can I implement X so it can't be misused? Right? And that's the piece most people skip in their fundamental design and engineering thinking.
Yeah. And so we have concepts like abuse cases, right? That's one of the ways that we try and highlight for developers that we need use cases, how's it intended to be used, but we also need abuse cases, which are ways that it could be misused or could be threatened, by negative actors. So one of the complications that is paramount in today's world is it isn't just the software developer hand coding everything that they are going to use in the system. Many of our developers use open source kinds of libraries, and then we have other elements of the supply chain. I'm using somebody's router that has software in it. And so, and sometimes those supply chains are 3 or 4 or 6 levels down. How do those aspects of modern software development complicate this problem?
Right. So reality is well over half of all software built today, we're like the 70s, 80 percentile of most software is actually either third party or open source software, right? And so from that perspective, an engineer needs to think about, just because I Googled something and this library showed up as the most popular in my web search browser, doesn't necessarily mean it's the one I should use or it's the most secure. And in open source, there really are some basic hygiene things you can do that are very easy to really bring down at least that initial set of risk, right? One is, if I'm doing open source, what's the number of maintainers, right? Does this open source library that I'm considering to use have a vibrant contributor community or user community, right? Why is that important? Well, if there's only one person maintaining this thing, well, you have just a sustainability risk that you're adapting, because something happens to that person or they decide they're no longer interested in it, you no longer have this tool or library that's being sustained and patched and maintained. The other part is, number of days since the last submitted. A lot of open source communities, you can actually see their process for contributing software. Is there a peer review process, right? Is it being evaluated and validated in some way? Like GitLab now, they provide the capability to run some basic static code analysis tools on their, using their open source community and some of their open source tools. So there's some basic hygiene stuff you can look at to make sure you're not making it too easy for your adversaries. Right.
Yeah.
And so at a minimum, you start there, right? Is thinking of those things. The other one can get you is like, if you really have access to like some intelligence and some other things, the people who are submitting code to these open sources, what are their usernames? What are their pseudonyms, right? Are those names associated with actual vulnerabilities and actual bad actors, right? Are they even hiding who they are a little bit, right? So these really basic things is really kind of the 101 analysis one should do when considering an open source application to include in your product or your service.
I mean, one of the things I've heard people say is you should treat open source like COTS. If you wouldn't, when you bring commercial off-the-shelf software in, you test it, you check it out in your environment, you check things like you're talking about, make sure the vendor's valid, all those sorts of things.
Right.
The vendor validity is something that is completely different in open source, but that idea of don't bring something in to your house until you've made sure it's safe is really the theme that you're talking about,
Right.
With both open source and other suppliers, right? That's the thing.
So one key difference is for open source, I would never take in a binary into my application. I'll take your open source, your source code, I will recompile it, I will put it in my own container if I'm doing Docker containers. I'm going to do all that myself. And I might even take that source code and run it through a static and dynamic testing tools to make sure there's no common weaknesses. If I have some access to look for, like an SBOM and go through, because even open source sometimes uses other open source.
Right. Yeah.
Right. So then I might look, was there any known CVEs associated with this application, right? If I'm purchasing an application, yes, maybe I will accept a binary from a trusted vendor, right? But even then, I should be thinking about and maybe even asking them, what does their software development lifecycle look like? How are they ensuring security in this binary that they're providing me, right? And really expecting them to do good engineering, just like I would expect my developers to do good, secure, thoughtful engineering practices. And if you are a big enough vendor, big enough procurer, those suppliers will answer those questions, right? Either through documentation or an on-site, visit.
Right.
And so, yes, you should definitely treat them both the same. That one caveat is I would never, download or use a binary from the internet. And people do it all the time, which just floors me.
Really?
Yeah.
The developers I know just do what you're talking about. They bring in the source code and a lot of times modify it, which is another aspect of you need to understand the open source well enough to know that your modifications are not going to create vulnerabilities. So there's all these cascading effects, really, is what we're
I think the
about.
biggest one is people out of convenience will take Docker containers from unvetted sources, right? Because it's convenient, it's easy. Now there are places where you can go get a trusted, like Iron Bank for DoD, right? Okay, that's fine. But Iron Bank will tell you their vetting process, their security controls, how they're managing that. So, okay, that's a trusted supplier of containers. But you'd be surprised, people still do it.
So you mentioned SBOMs, which is a software bill of materials.
Yep.
And that's one of the newer concepts in some circles. So why don't you just explain a little bit about what is it that an SBOM gives you that helps you with building secure systems?
So an SBOM, especially if you get like a third party break, they give you a binary, right? So you can't really just go through and look at what library calls or what other third party software it's using to exist. So you ask them for an SBOM. And there are some tools that will evaluate binaries and try to build some SBOM data. But the idea there is do I know what versions of what other aspects build this application? Because what I don't want is, take log4j or log, I keep saying it wrong. Example, most applications have logging capability. Well, most people don't actually build their own log capability. They get a library, right? And there's one, I'm going to say it wrong, but I think it's log4j. They had a known vulnerability a while back, right? Well, I want to make sure that version of that library is not in the version of software that I'm procuring or I'm adopting, right? And so an SBOM should be able to give you that information of, not only this is the name of application X, but it's made up of these 50 other applications and third-party open source vendor software, and what version of those things it is, right? Because then I get to take that information and I could look into any like CVE repository and say, okay, is there any known vulnerabilities with version Y of this particular subcomponent? Because if there is, then my entire application has a vulnerability, even though there might not be a known CVE associated with this application that I'm actually buying or using, right? And so that's the idea of an SBOM, is it gives me the hygiene and the pedigree of the application, and everything is used to make it what it is. Does that help?
So, no, I know there are some viewers that appreciate that. We're big proponents of SBOMs because of exactly what you're talking about, and it's not just the security aspect, but it's also in terms of quality. And if there's open source that works as expected, and then there's open source that looks good on the surface and not so much underneath. And so you want to, you want to know what you're getting, right? You don't want to be buying as this is a very old saying. You don't want to be buying a pig in a poke. So you want to know what it is you're getting to. So a couple of barriers to secure design that we've talked about. One is the developer either knowingly or unknowingly bringing in open source that is dangerous in some way, adds risk to the software that they're building. And then another barrier that we've talked about is the fact that the idea of giving the pedigree and having all the information about all your suppliers may be difficult to get. Not all open source libraries, sort of provide that kind of SBOM pedigree that you're looking for. So what are some other barriers? Are there any other sort of notable barriers to building secure solutions that you want to highlight today?
Right. So the other part is the actual engineering practices, right? So I mentioned abuse cases, but there is this concept of doing threat modeling. So if you are somewhat larger system, you may be doing model-based systems engineering. So if you do model-based system engineering, you have design diagrams. You have, basically a digital twin or design of what the system is that you're building, right? And you'll see this a lot, even in software for really large applications, especially if you're integrating your software with a big manufacturing thing like a boat or a plane, right? Because they're doing this stuff by default, and you're kind of fitting your software into their architectural construct.
Right.
But then you can step back and you say, okay, what's a threat scenario for this element or this subcomponent of my system, right? And you think about, what's the activity, what type of actors, right? Because not every actor is, someone outside your organization. You have insider threats. You also have just uneducated engineers who make mistakes, right? And so what action would they take? And then you also think about what the attack vector is, right? And so there's the MITRE KPEC that you could look at, which gives you very different techniques that an adversary could use to exploit your design, right? And so the idea here is if I develop some basic design scenario or threat scenarios, I begin evaluating my architecture against those things. The other one, even more fundamental, is requirements, right? And so people like writing user requirements, people like writing, system requirements, but they never stop and say, okay, what are my security requirements, right? A lot of people go, oh, well, just be compliant with this standard, right? So if it's the federal government, it's RMF, risk management framework. If it's in the banking sector or using credit cards, there's some other standards out there that they have to comply with, which hit a lot of security stuff. But compliance isn't a shall statement, right? And so there's lots of ways that I can be compliant with a standard, but not actually build a very resilient, secure system, right?
Yeah.
That requires requirements of intent, right? And I just say what I would expect, how would I evaluate that attribute of my system, which is more than checking a box for compliance.
Right.
And so, and reality is developers, they build to requirements. They don't build to specs, right? If it's not a shall statement, yeah, they'll read the specs. They'll try to make sure that's all impacted, but they often grade themselves by their ability to meet the requirements. So if you take the time and actually write good security requirements that can propagate to different levels of abstraction, to different levels of your subsystems, because not every piece of software is responsible for every security aspect of your system, right? So you need to take a holistic perspective to it. And that's, so you need to engage as part of the engineering lifecycle and engineering practices and stop trying to be this one-off, like come to the game and actually be a member of the engineering game and actually build something from that's what I'm saying to all those security analysts and security professionals, right? You have to engage with the developers. And a good bit of what I do is translate cybersecurity speak with engineering speak, because they came from very different backgrounds, and they don't. A lot of times they talk past each other.
Yeah.
Right. It's not intentional. It's just they have different vocabularies, and we need to translate those things.
Right. Right. So, good engineering practices, intentional security requirements, translating between the cybersecurity world and the engineering world, being I'll say a savvy consumer of open source, and your supply chain. Any other mitigations that you would say are kind of in your? I got one more for top 5 if you want the top 5 that you would recommend.
So you talk about secure by design is really becoming very popular and of interest to the global community. DHS, they're saying is secure by design, secure by default, right? So they've added a second element, secure by default. And what that is getting after is, as an engineer, when I build something, I deliver it to a user or an operational environment. Current practice in most applications, if you think like, any application you might buy off the internet or download, they make it really easy so it works in almost any environment. But what they do a lot of is they actually just turn off all the security features so it just always works, right? And so a lot of government folks or banking or heavily regulated industries, right, they spend a lot of time and energy hardening an application on a server or a system before their users can use it, right? That secure by default means I'm going to give it to you in a secure setting or secure configuration. Now, you as a user can decide to turn off some of those things, but it really flips the script. Instead of giving you an open, you're responsible as a user to secure it. I'm going to give you a secure application, and you as a user can decide to turn off the security features, but it's hardened by default, right? And so as a developer, as an engineer, you should think about that user experience and how to not incentivize them to turn off those features, right? Because if it's hard to use, a user will just turn it off because it's getting in their way, right? And so you've got to think about your mitigation. You got to think about your strategy for implementation to not incentivize that bad behavior of the people using your products and services.
And this has been, since the 80s, when I first got into this, the conflict between user experience, we called it human factors engineering then, but the user experience and quality attributes like security, they're known to be sort of conflicting quality attributes, because the better the user experience, unless I'm really smart about it, the lower the security, which is what you're just highlighting, and vice versa, that if I increase the security too much, it becomes a negative user experience, and I may lose my user or my customer, or they will find way. If it's easier to get around the security than to use it, that's a bad thing. And so this is arguing for me that we really need, and I don't know if this is part of the CERT strategy. I haven't really talked to anyone about this, but it seems like we need to get more training and education and user experience for our cybersecurity people so that they have a better understanding of what elements of their cybersecurity strategy may be impacting their users' willingness or ability to actually engage with the security practices that they're promoting. Does that make sense to you?
Yeah, I think almost everyone has experienced the password requirements that's so cryptic and so hard. You have no choice but to write it down because you have no way of actually remembering this password that you created to meet all their rules on how to create a password, right? And the reality is a password isn't what's secure, right? It's not sufficient. That's why we have so much multi-factor authentication now, right? A lot of people, even with you log into your bank account, right? You have to verify with a text message they're sending your phone, right? That multi-factor is something like your password, and something you have, like your cell phone, right? And so these things, they've always been fighting with each other. You got to work through it, and that's really where data comes in handy, right? So if I start collecting the user's experience and even build into my system some data collection in terms of how people are using my product, how they're using my application, I can very quickly see them turning off things or changing my settings, right? And the question is, well, why is everyone in my user community turning off this one setting, right? Do they realize how vulnerable they're making themselves? Well, one, maybe they do and don't care because it is such a pain for them, or they just don't know. And so then you have to educate, or you have to figure out what's incentivizing that behavior. That they went out and they looked for the way to turn this off, right? Because usually that's not like intuitive how to turn off certain features, right? And I do it even with my iPhone or whatever. Sometimes I'm like, this is driving me crazy. Well, let me go Google how to turn off that latest upgraded version where they turn something on, right? Yeah. And so those are the behaviors you look for. And if you answer these types of questions in your website, well, then maybe you can see, well, why is that page the most visited page on my website, right? So you can also think about it from your other internal processes and documentation, right? You can collect metrics that way too to get some insight onto like what your users are reading and looking into and what's on their minds.
And so this conversation highlights for me how rich an area secure system design is, and not just design, implementation, operation. And so I do want to encourage our viewers to look more deeply into some of the things you've talked about, because I know we have technical notes, blog posts on many of these individual subjects, as well as sort of the overarching work that you and your team are doing in the overall space. So kind of switching over to what are some of the transition resources that we have and that we can offer to our viewers to learn more about this? Do we have courses? I'm sure we have websites. We have websites for everything.
Right. So we have lots of SEI blogs. That seems to be where my team likes to publish the most, mainly because more people read them and it's more readily available. You can do web searches and they come up when you're interested in specific topics. The other thing we started to do, we have a secure software by design event. Our second annual is coming up in August. It's free. And what the idea is, the reason we did this is there's lots of security conferences out there, but what I felt is a lot of the security conferences are really focused on cyber operations, cyber defense activities, and not necessarily on the engineering practices used to build these applications, right? And so the real focus of our event is on the engineering aspects. How do I build better products? And so we have a rich agenda that's coming up. Like I said, it's like first week in August, I believe. There's still maybe a few seats left before we could hit our capacity, if those are interested. So that's one way they could do it. We do have some courses. We have C++ coding standards practices. We have a virtual course on software assurance that Dr. Carol Woody designed. And so we do have those things as well. Lots of technical reports, things of that nature. So we're really out there to just be a trusted advocate to tell people, because we're not selling anything, right? That's the great thing about the SEI. We're here to educate and improve the state of the practice, in software engineering, because we're the Software Engineering Institute. So yeah.
Okay. Well, and so for those, I know we actually won't get this podcast live before the event, but so for that Secure by Design event, I'm assuming you'll have some assets published after that people will be able to look at as well.
So we try to balance it, because there's lots of like virtual and semi-conference, so we really just wanted an engaged audience. And so what we're doing is this year, we didn't do it last year. Last year we just had it purely in person. This year it's still purely in person, but we're going to record the presentations. And so we're hoping to release those recordings post-production.
And we'll go ahead and we'll link to that event and its resources in the transcript. And we'll we'll link to other things that you've talked about here, the courses and the blogs that relate to this. All that will be in our transcript for our viewers. So thank you. I want to thank you very much for having this conversation. I always have a wonderful conversation whenever you come online, or even when we're just out in the world together. So I really appreciate you sharing all of this with our listeners. And I do want to find out what's next for you, because that's always intriguing to see. So what's coming, not just what's happening right now. So what are you going to be working on next, Tim?
So a couple years ago, model-based system engineering, things of that nature, we built this DevSecOps platform independent model. I think I might have talked about it.
Yes, we have.
Podcast. Yeah, I think me and Joe Yankel, we were both in that conversation, right? So there is talks of maybe actually making it a real standard, the standards body.
You're going to get into the standards world, are you? Okay, good luck on that.
We'll see. But yeah, that's currently a possibility. We'll see how it goes.
Okay.
So I'd like to get back into that and maybe updating it, doing a new release, a new version of it, because the practices and the technology is evolving. There's lots more cybersecurity elements that we could integrate into it than we did with the first. Well, actually, we have 2 releases now, so than we've gotten to so far. So I'd like to expand their security practices, make it a little bit more embedded, especially thinking of, and giving more examples of threat scenarios and how that really works into that process.
So you're gonna make that model secure by default.
We'll see.
Sorry, but I couldn't help myself. I'm sorry.
But that's the idea, right? Is how do I get these secure practices into engineering? And you're producing material and doing that to support other folks that can use it in education and teaching and universities. Because that's really where the industry needs to get to. We need to update that core discipline that the academia is teaching to include security of the next, software engineer, computer science major.
Right. No, that's critical, because that's the practices that they come out of school with are the practices that they bring to industry. And so if those are out of date or going in the wrong direction based on how technology is evolving, that's going to impact the quality of the software they build.
Right. So that's kind of where we're trying to get at.
All right. Your mission, you've got your mission set. So I look forward to talking to you in the future about how that's going. I've had a little bit of standards work in my past, and it can be rewarding. It can also be very frustrating, because trying to get a whole room of people to agree on anything
is painful.
It's challenging, and especially if what you're asking them to do is change their behavior, that's really what a lot of this comes down to, is changing the behavior of developers to doing more secure practices that take sometimes more time and that may be counterintuitive to the way they've been taught to work. So
right, and I think we're at a good spot where we're getting there with executive offices now having security officers in the C-suite.
Yep.
And things of that nature. People are asking those questions. People are wanting more security, or wanting it's becoming mainstream, the impacts of poorly secured software, right? In fact, airlines just experienced one recently, right?
I was there.
I was so glad I wasn't traveling. I was like, oh, it's a good week not to be traveling.
Yeah, right? Yeah. It was, as soon as they talked about it was a software issue, it's like, oh boy, here we go.
Right. and that was just a quality issue. It was a bug, from my understanding. It wasn't actually like a cyber attack or anything. And so again, quality matters.
Yep. Absolutely.
And so that's fundamental to our discipline, to our profession.
Yes. And I'm glad that you and others like you are taking on that mission, because it is very important for us all. And not everybody has the tenacity to kind of keep pursuing it. So that's something that I admire about all of you that work in that area. I just, it's funny, every time I've said this before, every time I do one of these security podcasts, I have a couple of nights of lack of sleep, because the scenario-based planning side of me just goes, and it can do this, and this could happen, and that could happen, and it's like, but that's why we need you, because I can't do that.
Because yes, sometimes ignorance is bliss, right? That helps you sleep well at night.
There are times, yeah. There are.
At the same time, it's like,
Yeah. All right. Well, I do want to thank you so much for joining us today and talking about this work. To our listeners, thank you also for joining us today. We will include lots of links in our transcript. Tim talked about lots of different things. And so we'll be giving you links to all of them and hope that you will use those. This podcast series is available in all the places you can find podcasts, Apple, SoundCloud, Spotify, and of course, my favorite, the SEI's YouTube channel. So if you have any questions about any of this, please don't hesitate to email us at info@sei.cmu.edu. Thank you.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, TuneIn Radio, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.